Hello, I am Ushashi and I am going to introduce a topic which is network optimization using artificial intelligence. First, I am going to define network optimization. Network optimization is a set of tools and techniques used to improve network performance and reliability. Network performance monitoring includes measuring traffic, bandwidth, jitter, and latency caused by the lack of infrastructure or inadequate network security. Network optimization is important because our interconnected real-time world is completely dependent on the reliable, secure, available 24/7 transfer of data. Every year, there are more and more demands being placed on networks. Every aspect of our digital lives relies on how efficiently the network operates, and that is why network optimization is so essential. Network optimization variants must satisfy three important requirements. First, adaptability to change the network conditions. Second, agility to ensure that adaptation occurs in a timely manner and with low network overhead. Third, efficiency to ensure that the network operating point remains as close as possible to the theoretically optimal. Increasing network agility and efficiency turns the network into a dynamic, programmable infrastructure built on analytics and automation, and it helps to meet growing bandwidth needs with on-demand scalability. We encounter another concept called network traffic. It is the amount of data moving across a network at a given point of time. Common network traffic issues include component failures such as router or firewall failures or traffic failures such as bottlenecks and high latency. To help ensure network quality, network administrators should analyze, monitor, and secure network traffic. Traffic optimization and scheduling requires in-depth perception and precise control of services, users, and network conditions, as well as unified management and analysis of network resources to form overall traffic optimization and scheduling strategies. Artificial intelligence is essential for helping customer service providers build self-optimizing networks, which give operators the ability to optimize network quality based on traffic information by region and time zone. Artificial intelligence applications in the telecom industry use advanced algorithms to look for patterns within the data, enabling telecom operators to both detect and predict network anomalies and allowing them to proactively fix problems before customers are negatively impacted. AI algorithms empower data predictions to be more accurate, and AI algorithms make the network have cognitive abilities and intelligent output capabilities. The problem with wireless communication is that these networks exhibit an inherent variability at many different levels and timescales. For example, optical fibers fail unexpectedly. The quality of wireless channels fluctuates rapidly due to multipath fading, etc. Traffic demand is emerging as a key source of spatiotemporal variability in modern wireless networks. This is partly due to increased network densification. A second key reason is the growing use of smartphones and tablets as a user's main internet access device, making traffic demand follow content popularity ebbs and flows.
Our goal is to automate the data network to satisfy the traffic demand. For that, we have to predict the data traffic. First, we need to observe the variability of the traffic demand. We consider a generic model lambda x comma t, which stores the number of units demanded from location x at time t. Units could be bits per second or packets per second. And then we have to find the pattern in the data collected. Recently, artificial intelligence methods based on deep learning have found significant success in solving complex pattern recognition and control problems. As a result, AI-based methods have attracted interest by the wireless community, offering radically different ways of approaching wireless network functionalities. The driving factor behind this trend are the abundance of large network data collected by software defined networks at various levels of network, and secondly, the fact AI methods are usually generic. The data collected will be inputted to these programs and they will give an optimized output signal to satisfy the traffic demand. Once we get the output from these programs, we distribute the signal according to the output and monitor the performance using the performance indicators. Performance indicators are nothing but few statistical functions on the data. Time average is average of lambda x comma t over a window around the area of interest. Variance captured by variance over a window in the area of interest tries to account for the fluctuation from average in that window. Regret is also a statistical function. This is measurement of accumulation of error, a kind of feedback into the algorithm. So there is a continuous feedback between the program and the traffic demand. Online network optimization, UNO repeatedly adopts the network configuration described to optimize performance as measured by various key performance indicators. UNO is concerned with optimizing a number of heterogeneous and even contradicting metrics such as network operating cost and quality of service. Combining different metric into one and applying multi-objective optimization to achieve Pareto optimal solution is always challenging. ONO can be split into three parts. Data driven optimization based on forecasts is the first part. There are different analysis techniques to perform this method, such as auto-regressive integrated moving average ARIMA model, which predicts lambda t. More recently, with the proliferation of neural networks, alternative techniques have been developed with increased efficiency. Examples of such models are recruit neural nets, hierarchical temporal memory, and long-term short-term memory. All these methods are particularly good at time series analysis of the data and give an accurate prediction of lambda t. And the second model is online learning. When the data monitoring is complex or training over entire dataset is computationally infeasible, it is preferable to use this technique that adopts decision on recently observed data. This draws from online learning, a machine learning method used to answer a sequence of questions given a data variable in sequential order. The third method is problem adapted AI. Here, training of dataset is done by reinforcement learning, starting from no knowledge of system and progressively train a deep neural network by observing performance indicators. We have seen AI plays a crucial role of predictor in network control and traffic optimization. AI algorithms empower data prediction to be more accurate. AI enables the network to have cognitive abilities and increase the efficiency of the network. Networks with AI technology will not rely too much on human experience. AI will continuously modify the network by reinforcement learning, thereby continuously improving the network.
Hello, hi everyone. My name is Ayush Sharma, and today I will be explaining the algorithms of our video assignment. Okay, so the first algorithm I'll be explaining is the greedy algorithm. So, greedy algorithm is an algorithmic paradigm that builds up a solution piece by piece, always choosing the next piece that offers the most obvious and immediate benefit. So this implies that the best or the most optimal solution of the given routing problem might never be reached using greedy algorithm, but greedy algorithm always will give us the local optimal solution, which over a period of time, reasonable period of time, can become the best solution available. Uh, so, uh, so basically, Uh, well, the greedy algorithms have many implementations in the industry, such as Huffman encoding, which is used to compress data, and even in Dijkstra's algorithm. So, why greedy algorithm does not produce the optimal solution is because it makes decisions based only on the information it has at any one step, without regard to the overall problem. So, if it is at layer two, it will not think about optimizing the path such that the total route from layer 1 to say layer 4 gets lowered, but at layer 2, which is the most optimal. So while making the solution, we can imagine greedy algorithms to be some of local optimal solutions. What that means is that at every stage the most optimal solution is being added up, and that of course is very obviously not, it may or may not be the most optimal solution. All right, moving on. The second is KSP algorithm. So KSP algorithm, or the K shortest path algorithm, gives us the K optimal path using a modified form of the basic Dijkstra's algorithm. So the core of the algorithm is Dijkstra, and it is a little bit modified. All right. So in this algorithm, uh, it asks not only about the shortest path but also about the next k minus 1 shortest paths. So uh, this entails, uh, in Dijkstra's algorithm, this entails that we are given a weighted directed graph with a set of vertices and a set of directed edges also, and cost of directed edge from one node to the other, say node 1 and node 2, are also given. What we are not given here is the heuristics. So in Dijkstra's algorithm, heuristics are not given, but the weights are given, and Dijkstra's algorithm uh, helps us find the shortest distance from each node to the source node. So say there are 5 or 6 nodes, and I select node 1 as my source node, then I'll get the shortest distance from each node to node 1. Uh, so and then I can select a destination node, and it will the KSP algorithm will give me the shortest path. Now this also may not give me the most optimal solution. Again, why? Because the node length is being measured from each node to the source node, and not necessarily the sum of the nodes. So uh, this, but still, again, like in greedy algorithm, this is also another form of greedy algorithm, because again we are optimizing in stages, and maybe like it is one it is a reasonable algorithm to produce a locally optimal solution. The third and final type of algorithm, which is the most advanced, more advanced, and more intricate than the other two algorithms we have seen, is the genetic algorithm. The genetic algorithm, of course, as the name suggests, is a heuristic search algorithm that is inspired by Darwin's theory of evolution and draws on the process of biological evolution. So, say after n generations of natural selection, the preserved individuals are all highly adaptable, and it is likely to include the individual with highest adaptability in history. So, this is the theory of evolution. Uh, this is applied in algorithmic form to find the shortest path. So as you can see, there are many stages. This is a very rudimentary flow chart for genetic algorithm, but it has stages like start, initialization, selection, crossover, mutation, and finally the end. uh, Genetic algorithm reflects the process of natural selection, where the fittest individuals are selected for reproduction in order to produce offspring of the next generation. So the 5 phases: initial, population, fitness, function, selection, crossover, and mutation, are what form the genetic algorithm. And how we do it is also in a way linked to the theory of evolution. How an individual contains genes which are themselves formed by a set of chromosomes. That is basically the principle which with which we assign the parameters to another individual, in this case a node in the routing problem. So each node is characterized by a set of parameters which are called genes in the genetic algorithm. And the fitness function in the genetic algorithm determines how fit an individual is. So again, then in the selection phase, we have to select the fittest individuals, or the most optimal nodes, and let their genes pass to the next generation. So again, that is used. And then there are crossover and mutation, which are, as the name suggests, crossover is crossing two nodes to get the best, most optimal path between those two, or in an evolutionary sense, uh, co- uh, breeding two individuals with the best possible set of genes to get the best possible offspring. And mutation refers to, in evolutionary sense, certain new offspring formed, some of their genes can be subjected to mutation with low random probability. So this is also applied in the genetic algorithm. And then the algorithm terminates if the population has converged, and thus the genetic algorithm provides a set of solutions to our problem. So that is the end of the presentation. Thank you, and thank you very much.